Good afternoon, everybody. Welcome to this month's webinar about camera lens technology, and we'll be covering a number of those for standard zoom lenses, varifocal, and a couple of other options. With me this afternoon, who will be covering a lot of the material, is Mr. Chris Royal from Fujinon, and he's the product manager and a few other hats that he wears with the company, and he's an expert in this field that we're going to cover today. Sometimes it's very much an overlooked item, but it's probably one of the most critical points of the part to look at. Just before we get started, we want to run through some general housekeeping. You'll notice that you are muted. You will remain muted for the duration of the webinar. Just to ensure that you can hear me, can you please click on the hand icon on the screen that you'll see? That's great. I can see lots of raised hands. You can now lower them. At any time, you can ask questions at the end of the webinar, but we'll cover the answers in it. But just remember to click on the send after typing your question. Right, I'll just hand this over to Chris, and he can take through some of the lens selections.
Thanks, Richard. Thank you for joining us today for the webinar, Choosing the Right Lens. This webinar covers a range and selection from the Fujinon range of security lenses. My name is Chris Royal, as Richard mentioned before. I'm the Key Account Manager for the CCTV product for Fujifilm and Fujinon in Australia and New Zealand. Our topic today is perhaps the most important section of the entire optic chain, and that is the point of capture. As we have heard in earlier webinar sessions, the importance of delivering a clean, crisp image to the network and recovery of these images is paramount. This session takes us to the source of those images, the lens. Understanding optics and accurately framing and capturing and delivering photons to a picture element within the camera is more than ever critical for modern security systems. Camera sensors resolutions have continued to increase with each generation of camera. So let's begin our overview of the Fujinon lenses. There are three types. First type is fixed focal. Next type is varifocal, and the third type is zooms. Each have their place in the market, but Fujinon have dominated the broadcast lens market where excellent image quality is required. The technologies for those broadcast lenses is now adopted into Fujinon CCTV lenses. To get us started, let's look at a standard specification sheet. This list is useful as a checklist to match the lens and camera to the desired purpose. The lens and camera specifications combine to give us the physical requirements and limitations for the lens, the camera, and the camera housing. Attaching the lens to clear up some of the main confusion on matching C mounts and CS mounts in Fujinon's coding and model numbers, a C mount is distinguished by a 1 and a CS mount is distinguished by a 2. So a simple rule is you can make a 1 a 2, but you cannot make a 2 a 1. As you can see, to modify a C mount lens to a CS mount, you do need the 5mm spacer. So just to reiterate the details, a C or a CS mount, a C can become a CS with a spacer, but a CS can never become a C. Otherwise it will remain out of focus. The other physical attributes are the dimensions and the weight that play into the housing and brackets necessary. All lenses can be fitted to a range of sensors. Here, once again, is our coding. Yep, that slide's fine. Okay. This slide illustrates our coding that we use for the various sensor sizes. So obviously a Y is a 1/3, D is a 1/2 inch, H is a 2/3, C is a 1 inch. There's a couple of other special ones that largely is for medical use, which is the 1/3 3 CCD type, which is a T, and a S for a 1/2 inch for a 3 CCD camera type. As you can see on the top corner there is each specification for each lens will indicate a range of sensors that it is capable of filling that sensor. And also it will illustrate the megapixels. So the camera can suit a range of sensor sizes, and the resolutions are nominated in the specification sheet. Fujinon CCTV lenses support resolutions from 1.3 megapixels and up to 6 megapixels. But perhaps before we move too far into our presentation, I would like to spend some time reinforcing some basic physics and images to explain some general rules for system design. Fujinon have developed a free application available from the App Store, which will be a focal length calculator. But I'll run you through this now. Okay, let's imagine that our practical exercise for today is we're at a train station. The camera and lens combination is 50 meters away. And we want to view a train that is 3 meters wide. There is our formula. So little f equals little y times L over y. Let's place some of those measurements into the formula. So our L is 50 meters. Which is our object distance. Our y is our size of the train, which is 3 meters. And our little y is our image sensor, which on the horizontal is 6.4 millimeters wide. And we'll replace those values in our formula. And we would come up with a focal length to capture that 3 meter wide image from that distance of 50 meters is 106.66 millimeters. Let's just try a different formula and say that we want to view from the same distance an object size that is 800 millimeters wide, roughly the size of a human's torso. Our focal length would then have to be 400 millimeters long. So let's move back into the products. Our first one is a fixed focal lens. Now fixed focal lenses, as the name suggests, it has a fixed focal length or an angle of view. These lenses are similar to a cinematography prime lens, as they usually only have one single optical element within them. The advantage of this type of construction is obvious, as less distortion occurs as the light only travels through one element. Fisheye lenses are a popular example of a fixed focal length. Fujinon developed the world's first 5 megapixel 185 degree lens. These are effective in blind spot free, wide area surveillance, such as subway entrances and shopping arcades. Next one. Partly, some of the reason why the fisheye lenses are so accurate is that Fujinon, in their broadcast television division, designed and improved the optical performance while reducing the overall size and weight. Aspherical technology enables one lens element to correct aberrations that would need three spherical lenses or three spherical elements to correct, making it a compact size, wide angles, and improved brightness, the f-stop. Let's talk about f-stop. Let me please explain the brightness of a lens. As this slide shows, it's fairly self-explanatory in lots of ways. A lens F number relates to the amount of light that can be gathered by the lens. This sometimes is referred to as relative brightness. An F number of 1 has a relative brightness of 1. An F number of 1.4 should be a relative brightness of 0.5, in other words, half the light. Each increase of one f-stop decreases the relative brightness of the lens by 1/2. A comparison of f number versus brightness is shown. This image demonstrates how a lower f-stop improves the quality of the image by providing clearer detail. Controlling the light is the domain of the iris, where there are 4 options available: manual, remote, DC, and remote iris, one more, which is basically being able to switch from DC to remote. Let's move on to what I call the Swiss Army knife of the CCTV, and is the variable focus, which requires multiple elements as the image shows. The range is adjusted manually at the point of installation, both the focal length and the focus. It is the Swiss Army knife of the security market, as they are easily adapted and focused per location. Next slide. Here is a schematic drawing of a shop scene. From left to right, you can see the difference of field of view in accordance with the object's distance and focal length. As shown here, the advantage of varifocal is to be able to adjust the image to suit the available location within the premises. Once again, we have slipped back into physics with transposing of field of view to angle of view. I won't even attempt to explain 2 times tan to the power of -1. But a general rule of thumb is to double the focal distance and halve the angle of view. Here is an example. 1.4 millimeter focal length is a 185-degree field of view. A fisheye lens. Double it and it becomes 2.8 millimeter focal length and a 99-degree angle of view. Double it again and it becomes 5.6 focal length with an angle of view of 49 degrees, and so on. But this all depends on the sensor size. Next slide, please. Here's another graphic image to demonstrate the effect of angle of view on different sensors. One question I get asked often: can I use a larger lens on a smaller sensor? The answer is yes, but do not. The answer is yes, but you do lose a lot of the image. In fact, it is like zooming. As you reduce the sensor size, or another way of thinking of it is placing a projector too far away from a screen, with most of the light shooting over the screen and hitting the wall. Plus, the remaining image that lands on the screen will have a lower resolution. The reverse is also true. Moving the projector too close to the screen will only fill a small part of the screen. That's enough physics. We'll move on to our last product category, which is our zoom lenses. Our range of zoom lenses are usually combined with remote pan tilt heads, typically used for 50 milli and beyond focal lengths. Very useful for remote observations, and they can extend to several kilometres. They are motorised with zoom ranges from 8 to 2,000 millimetres, and focus is maintained throughout the range. They are able to have a shot store or a preset, which enables it to return to a predetermined focal distance. Actuated extenders that can double the focal distance, and neutral density filters for bright environments can be engaged. Fog penetration models are available, and there are stabilizer versions and modules available for stabilizing the images on moving platforms. One of the great features of Fujinon zoom lenses is their ability to main focus throughout the entire focal range. We'll talk about some of the special treatments that are available. The most notable is day-night. As you can see, the night mode function of a day-night camera is becoming a big trend in the market, which uses the infrared zone area of 700 nanometers to 1,000 nanometers of wavelength in the light spectrum. So if you used a standard lens outdoors, the image would get blurred at night and would be needed to be refocused. By adopting a specialized optic glass and utilizing electronic beam coatings, we are now developed and realized an extremely low longitudinal chromatic aberration lens, making it possible for identification 24/7 without the need for any refocusing. Our last slide, this shows the effect of focal length on depth of field. The longer the focal distance, the shallower the depth of field. In other words, the distance between the foreground object in focus and the background being out of focus. Not a huge issue in CCTV lenses, as they are designed to focus to infinity. But be aware, on particularly long focal distances, this may be an issue. My last slide is announcing our new product, which is the world's first lens to support 6 megapixel high resolution for security cameras. As you can see, it is a 1/2 inch, very focal, with 2.2 magnification and 4.1 as its wide angle. So it's a 4.1 to 9 millimeter focal length, very focal lens. On our last page, we have some helpful links that you can go through. There is a YouTube clip highlighting the D60 zoom lens. There's also links to metric and imperial calculators that you can go to. Also, there's some other areas that you may find interesting in focal length and the camera lens format conversions. My contact details are there, Chris Royal. You can email me or call me on my mobile. And thank you for listening once again. Thank you.
Thanks, Chris. I hope everybody found that informative and a brief overview. It covers some of the basics of what you tend to use in the day-to-day environment, and especially some of the more important things that are coming up with day-night lenses as such. Again, Chris had some of his details up there for him in relation to Fujinon, but directly with Alarm Corp, if you'd like to know more about us, you can subscribe to our Alarm Corp Pulse newsletter. Go by looking at our website, and you can also contact the people listed below in the various states: Jeff Rushton, Diane Brazil, myself, or Steve Dinger. I'll just leave that slide up there for a few seconds if you need to scribble down any of the email addresses or phone numbers. And you can also find us on Facebook, LinkedIn and Twitter these days. Yeah, I hope this brief overview has been beneficial, and just wish to remind you that we do run monthly webinars, and for the rest of the year, every second Thursday on an intrusion-based webinar, and every second Wednesday of the month on CCTV, and the topics have been listed on your screen. You know, to register for those, you can just go and look at our website, click on the resources, and then go to the webinar tab. When you attend one of our webinars, you know, you've got access to special promotions. So for all purchases made online through our e-commerce platform, please enter the promo code as seen on your screen, JulyWeb14, and you'll receive an additional 10% off your already discounted trade prices. And this applies to nearly all of our product ranges, with a couple of exceptions that are listed in that there. Okay, let's go and look and see if any questions that are going to pop up through the course of the webinar. So put them up there and we'll have a look at those in that now. Well, a couple have appeared. One that we also, it comes up at time and time again, about the lenses, about having different ratings of megapixel lenses. You know, there are 1.3, 3, 5, and then the new 6 megapixel lens. About, can we put a 3 megapixel lens on a 1.3 megapixel camera, or vice versa? And what will happen? Chris, what's your opinion there?
Thanks, Richard. I get asked this question quite a lot. I find that in this point in transition where people are substituting or replacing the older style cameras with newer cameras, I think there's a tendency to think that we'll just take the lens off the old sub megapixel camera and pop it onto the new megapixel camera. Obviously, it's probably not the best way to go. I think it's more in keeping that you would tend to try and keep, say, a 1.3 megapixel camera with a 1.3 megapixel lens. Certainly putting a 3 megapixel or a 6 megapixel lens on a 1.3 megapixel camera certainly wouldn't give you a poor image. It'd probably give you a much better image. That always comes down to prices, in security. Whereas to put a sub megapixel lens onto, say, a 6 megapixel camera, you would be deteriorating your image quality.
Okay. Thanks, Chris. And again, it probably just marries, what's the best bang for buck? Like you said about, it's pointless really probably putting a 3 megapixel lens on a 1.3 camera. While it will work and it'll give you a good image, you're not probably getting the best value for money in that out of it. Okay. Okay, we did touch on about the CNCS mount lens types there. They're not interchangeable for there, and one requires a spacer and that for there. Is there a prominence of one versus the other that you find in the market, or what do people tend to come up with?
Well, that's a hard question. Sometimes I find that there's a lot of C mount which tended to be the shorter throw that's out in the field, and people are trying to either repurpose a lot of the lenses and putting them onto a C mount camera, and obviously they're getting a very fuzzy image. So if you're using a CS on a C type camera, you will only get a very, very blurry image. So it's really best to make sure that the camera that you have purchased and the lens that you've purchased are both the same types, either a C or a CS.
Okay, thanks, Chris, for that. We just might go through a couple of things about the summary, what we covered in that today.
Yeah, I mean, obviously we've gone through some of the rudimentary physics that you need to understand, but the camera and the sensor sizes are just continuing to grow. I've noticed in our new catalogue there is a 4K lens available, so it's very fast glass. As you can imagine, security will probably follow where broadcasters are going, which is a 4K sensor, which is 4,000 pixels across the top line by 2,000 down, and obviously that resolution will continue to grow. Day-night, I think I've explained the reason why it's best to put a day-night camera or lens out in the field, even in large shopping centres where, with a power failure, for example, a normal day lens would not be able to capture any of the movement once the lights go out. We've explained and gone through the C and CS mount options available, and once again, I hope that framing the image chart helps you, because obviously the position and the application will always be determined by the focal length, what you're trying to capture, and the housing that you have to put in it, put the lens and the camera in. And the last point that we'd like to make is that obviously a higher resolution lens will always work with a lower resolution camera. The limitations will be, obviously, a higher resolution lens will always be a lot more expensive than a lower resolution lens. Thank you.
Okay. Thanks, Chris. That concludes our webinar for today. I hope you found it beneficial. For any more information, please don't hesitate to contact us, and I hope you enjoy the remainder of your day. Goodbye.